Okay, my dear students, I think all of you are fine. Assalamu alaikum to everyone. Now, today I'm going to start lecture 8 for class 12. We'll discuss the subject physics, and our chapter is magnetic effect of electric current. It is the continuation of the previous lecture, and today our topic is application of electromagnetic effect. Application of electromagnetic effect in our practical life. There are so many places where we use electromagnetic effect, and we also construct some devices which are operated on the basis of this effect, electromagnetic effect. One of the very sensitive electromagnetic device is galvanometer. So I will describe you how galvanometer works, and then how we can change the range of a galvanometer. Galvanometer Actually, galvanometer is a device, very sensitive electrical device, which measures and also describes the existence of electricity in any substance. Okay, so in a galvanometer there are actually a permanent magnet having north pole and the south pole, and there is a magnetic coil. Okay, we know when electricity passes through any coil, then it produces a magnetic field, and due to these two magnetic field, an interaction occurs between them, and that's why when a needle is attached to that coil, then the coil is deflected. So when the coil is deflected, then we can get the idea how much electricity is passing through the device. So I am not going in detail of the construction of the galvanometer, but I am drawing simple construction for galvanometer, and I am going to show you how electricity passing through the galvanometer. This is the galvanometer device. With the galvanometer, there is always a small resistance is connected, and that small resistance is called shunt. So here G is resistance of the galvanometer, S means shunt resistance. So shunt is that which is a very small resistance connected in parallel to save the coil of the galvanometer, because you know galvanometer coil is very sensitive. If high current passes through the coil, then it will burn and the galvanometer will damage. That's why we use a small resistance parallel with the galvanometer coil, that is called shunt resistance. So let the flow of current through the shunt resistance is Is, and galvanometer current is Ig, total current is I. Okay? So I can write here galvanometer resistance of galvanometer, resistance of galvanometer, resistance of galvanometer, G, resistance of shunt is S, flow of current through the galvanometer, flow of current through galvanometer, meter is Ig, and flow of current shunt is Is. Total current of the circuit, total current of the circuit be I. Let us find how much electricity will pass through the galvanometer, how much electricity will pass through the galvanometer. Then we can understand how much what amount of shunt resistance is required to confirm the range of the galvanometer. Okay, so you see these two are connected in parallel. So I am going to find the relation between total current and the shunt current, total current and the galvanometer current. Okay, so let us find it. Now let this point be A and this point is B. So the potential difference across AB for the galvanometer is Ig into G, and for the shunt is Is into S. This is the potential difference because they are connected in parallel, so both these potential difference will be same. Okay, so here I write here S and G are connected in parallel. Therefore, the equivalent resistance. 1 by Rp equals to 1 by G plus 1 by S. It is Rp equals to Gs by G plus S. Now, potential difference across AB, VAB equals to Ig into G equals to Is into S. Okay, so I think you got the point. Is into S equals to I into Rp. That's why Ig equals to Rp means Gs by G plus S into divided by this G goes in this side, so 1 by G into I. There is G cancel, S by G plus S into I. And similarly, the shunt current will be G by G plus S, G by G plus S into I. These are the expressions for the galvanometer current and shunt current. So I think you got the point. Of galvanometer current and shunt current. Okay, now I'm going to describe you how you can change the range of a galvanometer. Range of a galvanometer like ammeter. How can we change the range of a galvanometer? Okay, few minutes back I drew a circuit of a galvanometer, and in ammeter the shunt is connected in parallel. It was the shunt resistance, which was the galvanometer resistance, flow of current was Ig, the flow of current across the shunt is Is, total current is I. Okay, now let us replace this total one, G and S, in total one, the total resistance of the galvanometer, we are, total resistance of the galvanometer, we are, I draw a new, after changing this shunt, I include another small resistance in parallel with the shunt, so that the total equivalent resistance will decrease and it can measure more current. For example, the galvanometer current is Ig. You have to measure the new galvanometer current is Ig prime equals to n times of Ig. This n is called multiplier. Okay. So now to measure this amount of current, for example, you can measure 10 ampere, but we want to measure 1 ampere. So 10 milliampere and 1 ampere is a very big difference. You can measure 10 milliampere. Now we want to measure 1 ampere using the same galvanometer or same ammeter. Then what we can do? Now we change this construction. Here is the total resistance of these two, and I connect a new parallel resistance is Rp, so that it can now the new current through the galvanometer is Ig prime, and the remaining current passing through this shunt connected newly with this galvanometer be n minus 1 Ig prime. The remaining current, the total current, one portion passing through this galvanometer and the remaining portion passing through the shunt. Okay, passing through the shunt. The total current is Ig prime. The total current is new current that the galvanometer can measure is Ig prime. So now how much shunt resistance is required? Okay, so now see, now these are connected across AB in parallel. So here the potential difference VAB equals to n minus 1 into Ig into RP equals to Ig into G. Ig into G. So here the new resistance V, the new resistance of the galvanometer V R, including these two. This R is including these two. So here we write R. That's why RP is R by n minus 1. So if we connect the small resistance RP in parallel with the total resistance of the galvanometer, then we will get n times more current through the galvanometer. N times more current through the galvanometer. So let the total current is Ig prime, it is n times of Ig. So one part of Ig, only Ig is passing through the galvanometer and the remaining portion is passing through the shunt resistance. New shunt resistance is Rp. So Rp equals to R by n minus 1. This is how we can change the range of a galvanometer or ammeter. So I think you got this point. Now I am going to discuss how we can change the range of a voltmeter. Okay, now you know in a voltmeter, the galvanometer coil, another big resistance is connected in series. Okay, it's connected in series. So let the current passing through the galvanometer is Ig. So it is connected in series. So what is the total potential difference? We have to know what is the total potential difference. The current total potential difference V equals to Ig into G plus R. That's why Ig equals to V by G plus R. Okay. Now to increase its range, it can measure up to V voltage. Now to increase this, let the new potential difference be V prime. New potential difference is V prime. So what will be the V prime? V prime equals to n of V. V prime is n of V. That's why we can write let new resistance R prime be connected in series with the galvanometer or voltmeter. So this one is total one. Now is including these two, we add a new resistance R prime. So here we add a new resistance R prime. Okay. So in that case, what will be the potential difference? In that case, the same electricity is passing through all of this. So in that case, G prime equals to NV equals to IG into R prime plus R prime plus RS. This total one we include series resistance RS. So RS. Here R prime means G plus R, including these two RS. Okay. Now we get E by so R prime IG, actually IG was I discussed few minutes back, V by G plus R. So if you write it, V by G plus R. So in case of IG, you can write it. So then we get RS. Then we get RS equals to R prime into N minus 1. New RS equals to R prime into N minus 1. Okay, so this is the expression for the resistance required to change the range of a voltmeter. I think you got all the points that I discussed. First I discussed how to change the range of a emitter, and now I discussed how we can change the range of a voltmeter. Okay, its actual range is V of the voltmeter, but we want to find new range. We want to change the range like V prime is NV, N times, where N is the multiplier. Then how we can do it? We will add a resistance RS in series with the total resistance of the previous galvanometer. And what will be that value of the RS? To get N times amplifier, N times magnifier, the required resistance must be RS equals to R prime into N minus 1, where R prime is G plus R. So thank you everybody watching this video, and who are observing the class. Thank you everybody. I think you understand the points. Later we'll discuss mathematical problems on this topic. Allah Hafiz.